Hello friends, my name is Bobby Thomas. Today I am going to take you through a reference architecture for deploying microservices to AWS. Here is the agenda for today. I will first give you an architecture overview. Then we will create two simple microservices and Dockerize it and push to ECR, AWS Elastic Container Registry. Then we will create the complete stack all the way from creating VPC to deploying the services. And then we will test the microservices. Okay, let's get started. In this example, we will be deploying services into AWS using Docker containers. The services can be built using any language or technology as long as it can be Dockerized. Once it is containerized, we can test it locally, make sure that the container is fine, and then replicate into n number in AWS as we wish. It comes with a network designed for security and high availability in mind. We provision all the infrastructure required to deploy the services, right from VPC, network links, internet gateway NAT, etc., multi-availability subnets so that the service is highly available, public subnets exposing service to internet, logs to CloudWatch, and application load balancer and target groups to send appropriate traffic to services. For example, if you have service 1 to fargate task 1, service 2 to fargate task 2, etc. So on a high level, this is how the architecture looks like. We will have a VPC with a CIDR block of 10.0.0.0 divided by 16. We can have up to more than 65,000 IP address available in the network. We will have an internet gateway attached to connect in and out of traffic from our clients to the internet. We will have 4 subnets in the VPC in this design, 2 public facing subnets in each availability zone and 2 private subnets in each availability zone. Basically, each availability zone 1 will replicate whatever is there in availability zone 2, so that even if one entire zone goes down, we still have the service available to our clients. As you can see, we have a NAT gateway attached in the public subnet. This will be used for any outbound traffic coming from the fargate task or any of the EC2 instances in the private subnet. We will have private subnets to deploy all our ECS clusters. We will have fargate task defined with ENI network elastic network interface exposing the services. We will have a load balancer taking the traffic from internet to our fargate task. All the fargate task will be sending logs to CloudWatch, so you can easily monitor what's going on with the services. And the fargate cluster, ECS cluster, will look after the service availability, make sure that the number of instances specified will be running all the time, etc. All the code related to the reference architecture can be found in the GitHub link. As you can see, it has some instruction and some basic script to do some task really simple. There are services folder. Under that there are 2 services, which is basically pretty simple, mimicking microservices. You can see a customer service and an order service. Also, we have a CloudFormation script, which basically a bunch of script to provision the infrastructure what we need. Now let's quickly build this project. So to build, I have some helper script. All you need to do is build. It should generate 2 Docker images for each of these microservices. Now let's quickly test one of the service just to give an idea how these services look like. So what I will do is I will run one of the, let's say I'll run customer service. Yeah, the service, the local Docker container is running. I'll just run the health URL. you can see it just gives an instance ID, which is a unique ID for the container running. So every time you start a container, container gets a unique container ID. I just added this to uniquely identify which container is serving your request, especially in AWS. When you provision multiple instances, we can uniquely identify whether it's served from same instance or different instance. Otherwise, the health status says there's a version of the service and also a status indicating okay or not. Now, if you look at the customer service, it's again pretty simple. It has a URL customers and the customer ID. It just returns a ID as the number you passed and the name as name space the number. So if I put it to something longer, you get that number back. Nothing fancy, really basic microservices. Now, exactly same thing for the order service as well. So let's stop that. Let's push these images. Now, before pushing these images, you have to create an ECR, Elastic Container Registry repository. So it's pretty simple. If you are in ECS repositories, you just need to create 2 repositories. This is where we keep our Docker images for provisioning later. So once you have that, you can basically run the script, configure the script, and run the script to push the images to Docker registry in AWS. Now, I already have these images, so it should be pretty quick push. Yes, it is done now. So basically, you can see all the images inside the repository. Or there's an order service and customer service. Okay, let's quickly deploy our microservices into AWS. First, let's switch over to AWS console. Before I create the stack, let me show you that I have a plain slate. So I am in Sydney region. I will quickly switch over to VPC. As you can see, I have only one VPC, which is default. I don't have any subnets, 0 subnets. NAT gateways, I should not have any. Okay, it's deleted, so I don't have any existing NAT gateways. Also, I will switch over to Elastic Container Service. I will show you that I don't have any clusters or task definitions present. So first, let's go to CloudFormation and create the VPC. Choose VPC. Next, MS demo, VPC, MS demo. Create. Okay, so let me quickly show you the template here. What it is going to do is it is going to create a VPC with 4 subnets inside, 2 in each availability zone. For every availability zone, we'll have 1 public facing and 1 private facing subnets. So basically, if you go back to the architecture, it creates the VPC, internet gateway, the public and private subnets in each of these availability zones. Okay, now the creation is complete. Let me quickly switch back to VPC and show you what we got. As you can see, we have 1 extra VPCs. Let me quickly show you that same as demo VPC. In subnets, we have 4 new subnets now, 2 private subnets and 2 public subnets. If you look at the private subnet and route table, there's no connection to internet, and the public one, we have any connection to internet, go through the internet gateway, which we have created just now. So that's great. Now let's go ahead and create a NAT gateway. Okay, let me quickly show you the template here. The resources we create is we create an Elastic IP inside the VPC, and then we will create a NAT gateway inside public subnet. Also, we update our private route, saying any connection inside the private route to internet go through the NAT gateway. So if you look at the architecture back again, we create a NAT gateway inside public subnet, and then add a rule in private subnet saying any connection to internet go via NAT gateway. Now, in this example, it is important to have a NAT gateway because when we define the fargate task, we have to specify an image, Docker image URL. It could be either in Docker Hub or it could be in Elastic AWS Container Registry ECR. Now, either of them, when we have to pull the image, it has to go through internet and pull it down. So, which means we need to have internet connection available in these private subnets. Okay, NAT gateway creation is complete. Now, let me quickly show you the VPC. NAT gateways, we have the MS demo, new NAT gateway created with an IP address. Let's quickly look at the subnets. So if you look at the private subnets now, it should be redirecting the traffic to NAT gateway for any internet connection. So that's great. Now let's create a load balancer. Okay, let me show you the template. What we do here in case of a load balancer is we create a security group for the load balancer and we create a load balancer and a dummy target group. Now, if you look at the architecture, we create application load balancer for any incoming API calls, and the application load balancer will redirect traffic according to the path to the relevant fargate task. Let's say, for example, if you have a call to /API/v1/customer service, it will redirect to a fargate customer service task. Likewise for order service task. Now, this is achieved through creating target groups and listeners. Okay, now the load balancer creation is successful. Let me quickly show you the load balancer. Go to EC2, load balancers. Yes, here is a new load balancers. It's actually created in, it's linked to public availability zone. We have a new listener. If you look at the rules, there are no rules at the moment. It's just redirecting default target to a dropout. Nothing is configured. As we deploy new microservices, we will add rules to say, okay, customer service, go to this target group, etc., etc. Now, okay, now let's go back and create a cluster. Before I do that, let me show you that I don't have any clusters present. Let's go to CloudFormation and create a new cluster, new ECS cluster. As part of this stack creation, we create new roles, IAM roles, identity and access management roles, for allowing the fargate task to download, pull Docker images, etc. So we need to acknowledge that creation of new IAM roles. Okay, the stack creation is in process. Let's quickly look at the template and see what's going on here. You can see it creates the resources are ECS cluster, fargate security group, and link to the load balancer security group. Also, we create a couple of rules. Let's say take an example of task execution role. It has getting the token, ECR token, getting the images, etc., etc. Okay, so the task ECS cluster creation is complete. Let's quickly switch back to ECS and see the cluster. Okay, we have a new cluster now. We don't have any services running. No task present, but we have this cluster ready. Let's deploy the services now. Let's choose customer service first. Next. We will have two desired count. We will give the environment a name MS demo. it's already pre-configured the URL, but if you want to update, you can update. It's just pointing to the latest image of customer service, and we are saying the path is any, this is the path we configure in the load balancer. Any call to this path redirected to the new fargate task. Let's next, create. Okay, let's look at the template quickly. As you can see, a lot of them are parameters, but basically it creates a ECS task and a service and link them together, and also update the load balancer target group to point to the new fargate. Okay, so we have the first service, customer service, deployed now. Let's look at the let's quickly test that. Maybe I'll quickly show you the task first. You can see the cluster. We have one service running now with two running tasks. If I switch back to CloudFormation, let's quickly test it exports. We have the load balancer link, copy the link. Let's switch over to the control v / API / v1 / customer service / health. Okay, so we have the health instance running. So if you if you look at the instance ID, you can see it's a unique ID representing the instance running. If you refresh that, you can actually see it's first part is actually same. Probably you should look at the last part, 3E43. If I try again, it's actually changed. So we have two instances running, so it's actually switching back between those two instances. So it's actually doing round robin in the load balancer. So that's great. We have the first service up and running. So let's deploy the second microservice. So let's go back to CloudFormation again, create stack, choose the service. Let's deploy our order service now. MS demo order service. So again, we have to specify the image URL, desired count 2. The environment is very important, MS demo, and this URL linking is order service. Next, create. So we are deploying our second microservice now, which is the order service. And while that's happening, we can actually look at the customer service, customers / let's put 3434. So you can see ID 3434 and name 3434 coming back. So it's hitting the customer service. Let's switch back to the order service and see what's the status. Okay, creation is still in progress. Okay, so the order service is deployed now. Let's quickly go back to the container service. You can see we have two services running and 4 tasks running there. Task definition, we have 2 task definition, order service, etc. Let's quickly test the service. So instead of customer service, let's test the customer service. Is still running as expected. Let's go back to order service / health. Okay, so you can see it has got a different instance ID. Of course, it's a new container, and you can see it's also switching between the 2 instances. Now let's look at orders / let's look at 77777. So you can see it's returning back the order ID. It's pretty basic stuff. So if you go back to the Elastic load balancer again, EC2 load balancers and the listeners, and look at the rules now. We have 3 rules. Any call to API / v1 / customer service forwarded to customer service, and API / v1 / order service forwarded to order service. If you look at the customer service, you can actually see the ARN of the customer service target group, and you can actually see the registered target's IP address. You can actually see we mentioned that we need 2 instances. It actually created in 2 private subnets. You can see the subnet 100 and subnet 2101, which are actually in availability zones 2A and 2B. So it actually evenly distributed the creation. Even though we have specified we need two instances, it automatically created two instances in two different availability zones. So in that way, fargate behind the scenes looks after distribution. If you specify one, probably it will create in one of the zones, but if you specify more than one, it will distribute evenly across different targets. So likewise, let's go back to the load balancer again, and let's look at the listener rules and the order service. Probably the same thing here as well. Targets, you can see 100 and 101, it has got two different IP address instances created behind the scene, which we don't know. If you look at EC2 dashboard and instances, you don't see any instances because these instances are not EC2 instances in a traditional way. These are instances managed by fargate services. So that's why you don't see any instances, but behind the scene there is an IP, etc., associated to the fargate containers. Excellent. Okay, so we can see we have successfully deployed our microservices, order service and customer service. Let's look at the CloudWatch logs. Let's switch back to CloudWatch logs. You can see customer service. You can see the API calls being made. So it's customer service health call is happening frequently and every customer call. Let's make a call on log groups, order service. Let's put one of the stack. So you can see it's doing health regularly. 777 was the call we made. Let's change it to 123 123 123 and make a call. So it's, you can see the response here. Let's switch back to CloudWatch and refresh this. So it probably would have gone to the other instance. Let's switch back and see the other one. So you can see here the API call, it's being logged 1231. So basically all the logs are going into CloudWatch from these microservices. Thank you very much for watching this. Please send your suggestions or comments or improvements or anything in comments, and I will try my best to address some of them. And thank you again for watching. See you later.